Day one, like day 7. Yeah. What was your name? Yeah.
I'll call on someone in about 15 seconds.
Oh, two. Sorry, 8 point. Like the things with the stuff. Wait, what? I'm like, what did you want? What?
Same size.
Oh,
Okay. So,
Oh, I see.
did you draw a picture?
yeah, yes.
Are we good with drawing a picture for this? Or can we keep it in our heads? Like after you draw it, do you see that you have SSA?
Yeah.
And could you see that just from this list, they have SSA?
Yeah.
And if the swing side is A, does that make sense? The swing side is A because it's, yeah, across from the given angle. And also, Kimmy, what was it that you said? It's shorter than the other given side, so we know that there might be two triangles, right? So you could draw it, which is great. It's definitely important to be able to analyze it. But once you kind of know how the pieces fit, you can start streamlining your efforts. Sophia C, can you tell us what you did for this one? How did you start?
Oh, well, like I drew a triangle.
Nice.
And then like since it's like SSA, that means like there can be like two different like triangles with like two different side lengths.
Perfect.
SP.
Okay, so you kind of have the big picture is what I'm hearing. Okay, so then you got into it, and what did you do?
Then to find like B, I did sine of 35/8 equals sine of B over 10. So then sine inverse is sine 35/8 times 10.
So sine 35/8 equals sine of
B over 10.
B. Okay, I missed that. Over 10.
And
Okay.
then it's like sine inverse of sine 35/8 times 10 is B.
Nice. And what do you get there?
45.8.
45.8. 45.8. Did anyone else get that? I'm seeing lots of head nods, thumbs ups. Great. These are good signs. Do you want to continue?
Yeah, well, to find like the third angle, then just like 180 minus them. So like 80.8.
So 80.8.
8.
See, this was 35, and this is.
Oh wait.
Oh, so these sum to 80.8. I see what you're saying.
Yeah.
Okay.
Yeah. So then 99.2.
99.2 degrees. And were you able to get the length of the side C?
I didn't put that in the calculator yet, but I did like 8 over sine 35 times sine of 99.
Okay, wait, you said, can you tell us your equation that you're using one more time?
8 over sine 35 equals.
And we'll use 8, right? Maybe that's
Yeah.
what you said. Okay, 8 over. Yeah, equals.
C over sine 80.8. Or 99.2.
So 99.2. And just to keep the variables consistent, let's put a C up there. Okay, are we good with that? Yeah, and I imagine that once you're here, it's a matter of getting your hands on a calculator and not missing a button you're trying to press. So you haven't gotten to that yet, but thank you. So what is the answer? If you know it on the count of 3, I just want to hear it. Okay, 1, 2, 3. What is it? 36.768.
13.
That makes sense. 13.768. That's what you get when you listen to 20 students. Yes, Amir.
How many times what would you take off if we like showed our work while we made a mistake?
Yeah, I would. So make sure to show your work because at least I have something to fall back on. And it also depends, if you got 3.768 here, then there's kind of a glaring error, isn't there? If your calculator said that. So I would need you to say something's wrong, or some acknowledgement, depending on the time. Eileen?
Would you pick up points for rounding to 2 decimal places instead of?
Yes. Yeah, unless otherwise specified, for length, I want 3 decimal places. For angles, I want 1. And if it says something else, please make sure to adhere to whatever it's saying. I know on the problem set you're about to do, it's going to say 2 decimal places for everything, I believe. And it marks it wrong if you do too few or too many. So thank you for asking. Okay. And Sophia, thank you for your help. We'd like to continue with the second triangle. Yes, Levi.
So to start, since A is given, stay the same, and then I did 180 minus 45.8 to get the angle of the other B, which is 134.2 degrees.
Okay, one moment. Are we okay with that, everybody? Can you visualize that with what we did on the that board from last time, that those 2 angles are supplementary? That's exactly how to crack into that second triangle. And then could you just tell us the other values you got? You don't have to tell us how.
For the C angle, I got 10.8 degrees. And then for the length of C, I got 2.614.
Are we good? Just doing a once over, does everything line up? Yeah, the 134 degrees definitely opposite from the longest side, so we're good. Thank you, Levi. Yes.
I'm sorry, could you draw it?
Sure. Yeah, so I always keep the angle when it's the SSA. I keep the angle in the lower left. So 35 degrees. I'm going to approximate look something like that. What do you think? So I have my 35 degrees right there. I do want to make it fairly accurate. I don't want to make it like 80 or 10. I want to have some degree of accuracy. And I have the 35. I haven't done the swing side yet. This is a swing side here. So whatever I make this length is going to be my 10, and that's kind of arbitrary. So 8, I'm just going to have to make sure is kind of close to that. Now, can you all visualize that the 2 different places where 8 could fit and keep that angle? That one is like over here, or that could swing over to here. Maybe like that. I'm trying to get a little bit smaller than 10. But I hope that helps.
Yeah, I just drew my.
Okay.
How do you know which side the text has to be on?
If it's SSA, which we can tell right here it is. Yeah. Any other questions? Yes, Emmy.
Mines don't have to be to scale like that, right?
They don't have to be to scale. Definitely not. It helps for visualization purposes, but I'm not going to take off for it. Something that is not to scale unless it leads to something that's just wrong. Any questions? Okay. I have a question for you. For SSA, what if the angle is obtuse? Now, all the ones we talked about so far were acute, weren't they? Leading to an ambiguous case. But what if the angle is obtuse? Would you still have an ambiguous case? Please discuss.
I was like, all the angles combined, it's like.
I don't think that's right.
It's like.
Saying,
That would be like the wrong.
This side is like.
Is it the style?
Oh, yeah. So I think it was.
Oh, yeah. Yeah. Like I played both sides.
It goes along, so this is. And if we only.
no, but then I don't think if you give it angles. Like a.
Right. The triangle. So. It won't.
Okay, so what do you think? Is there ambiguity?
No.
No ambiguity. Although it had to be true is that the second side has to be
Greatest side.
longer. I don't know. Yeah, it would have to be the greatest, wouldn't it? Well, would it be the greatest? Greatest? It would, wouldn't it? Because opposite the obtuse. Could there be another obtuse angle in the triangle? Yeah, I think that might be difficult. Yeah, so you're right. It would have to be not only the longest side, but longer than that first side, the fixed side. And they're both fixed here. So for SSA, if that angle is obtuse, you wouldn't have to worry about a second triangle. So it's only when the angle is acute. So just wanted to finish off that concept. Last thing for solving triangles. Let's get to the packet. What page is this?
9.
Page 9. Will law of sines work for this triangle?
Be a lot.
Why won't law of sines work here?
It's not side.
It's a side. You don't have options.
There's no.
Yeah, there's no opposite side and angle, right? Everything that's opposite is unknown. At least one of them is unknown. So we don't have side angle here. What would we call this case when we're talking about like our geometry? SAS. And whenever you have SAS, you cannot use law of sines. It's not going to be helpful. You just go round and round and round. So SAS. So, and I'll continue my notes up here in a minute. I guess I have to tell you the new formula, don't I?
Yeah.
Now for law of sines, it was kind of a nice derivation, wasn't it? With that height in the middle of the triangle, it kind of popped out quickly. Law of cosines is not quite as easy to derive. So I'm just going to tell you what it is. And if you really want to find out where it came from, just meet with me a little bit later. But it's going to start off familiar. It looks like that c squared equals a squared plus b squared, but there's more. Minus, anyone know this from their ACT studies? Minus, yes, 2ab times, what's the law of cosines? So it's times the cosine of c. Now, okay, this first one is, of course, this is a little c in the beginning, right? You don't square angles, you square sides. So sorry I didn't make that clear. So there are two more versions of this. The good news is they're all the same. And what I need you to notice is that these two are just like the opposite side with the angle. And then everything else just kind of falls into place. Like if I were to start with a squared, then they would be equals b squared plus c squared minus 2bc. Shane, did you say this before? Right, well, it's just the relationship, right? Times cosine of a. Done. So don't worry about, oh my gosh, now I had to memorize 3 new formulas. It's all the same thing. So go ahead and write the next one. I'm going to call someone to read it or tell it to us if you want to just quickly check with your neighbor. Christine, what'd you get? Cosine of b. Are we good? Thank you very much. Does the angle have to be in degrees or radians? And these we're normally talking about degrees when we're solving triangles, but it's either one. It's if you're talking about radians, it'll be in radians, normal degrees. Okay, so for this one, I don't want you to think, oh, which one of the 3 do I have to use? You see which angle we're using, right, Nico? It's plain to see that it's 45 degrees, which means I'm going to start with b squared. Is that clear?
Yeah.
And I'm not going to think, okay, what's a, what's b? I'm just going to do the other ones. equals 2 squared plus 4 squared minus 2 times, dare I say 8? I'll keep it 2 times 4. You can say 8, of course. Times cosine of 45 degrees. I'll give you a minute to finish solving this triangle. Yes, unless otherwise.
Is this? Exact value? No, you said round, like round to the same thing.
So side's the nearest thousandth. Angle's the nearest tenth.
Oh, wait, I have to take the square root of this.
Are you getting it?
Oh, this is really good. Yeah, no, yeah, I know some shouldn't think things out.
You think the main for cosine.
Oh, yeah, no, I see.
I didn't hear no.
No, I see, I just wrote, I did a lot.
Right, five cosine or something like this. I mean. So I'm gonna try it. Sure.
Like fun. You just even start up with long song. Okay.
On what part did you go on? Didn't go well. But that's.
Are you done?
Yeah.
Like-
Here's number 1. Okay, let's see what you got here. Okay, Kimmy, look at that. You recalled. What'd you get for B? 2.947. Do we agree? Thank you very much. So you got B. I should make my chart here. A, B, C. I think we know the other two. 2.947. A is 2. C is 4. And B is 45 degrees. Did you get the other angles by any chance?
This is.
What'd you get?
28.7 degrees and C are about 106.
100 and
Whoa.
Yeah, I got.
0.3. Are we good?
Yeah.
I'm seeing mixed results here. So which one do you get first? 28.7 or 106.3? Okay, so it's 28.7.
I did sine of 45 over 2.927 equals sine of A over 2. So sine inverse of 2 sine 45 over 6.9%.
So sine of A over 2. So from here you get A is approximately 28.7. Are we getting something else? But aren't there 2 possibilities for that 28.7? Could it also be that supplement? Like 151.3? Why not?
Outside, it's over. It's over.
Yeah, it's over 180 if you try to do ambiguous case here. That's only for the ambiguous case. You're gonna be looking for two different values. Okay, so the 28.7, I'm taking it, and then we just left with 106.3. It's nice because that biggest angle, right opposite from the longest side. Things seem good.
Excellent.
Thank you. Okay, this one. Oh, yes.
I saw for C first.
Yeah.
Yeah, and I got a different answer.
Oh, you got self for C first.
Yeah.
Ah. Yeah, this is a little bit of a problem, isn't it? If you solve for C first, this is great. Thank you for bringing this up. 2.947. So you got sine of C over 4.
What's wrong with it?
And there's nothing wrong with this. So C equals, in this case, you get C equals
73.7.
33.7. Okay, nobody raised anything. I'm gonna take this. Oops, I'm gonna take this and put it over here. I missed the one. I could just write it over. Okay, 28.7. Okay, so 73.7, which means that you got what for A?
61.3.
61.3. Okay, so when we take a look at this, is there any problem here?
Wow.
It's a little bit of an issue, isn't there? Just check to make sure your neighbor sees the issue here.
Oh, yeah.
45.
So the math was really good, right? But we ended up with something that just is, it's what's it called when you have that proof that ends in a contradiction, right? We have contradictory information, which means something went wrong. Now take a look at these two numbers. What do you notice about them?
Let me change it to
They're supplementary, aren't they? So we actually had to use the supplement of what we got. Now, how can we avoided that? By saying, wait a minute. Once you have the three sides, this C may, what the heck, be obtuse. Isn't that a possibility? It might be obtuse if it's the biggest angle. Law of sines will not give you an obtuse angle. Does that make sense? Law of sines won't give you an obtuse angle because sine inverse lives in quadrants 1 and 4. So it's only going to give you a quadrant 1 angle. So if you see something that might be obtuse, maybe don't choose that one. That's why when Kimmy chose A to do first, is it possible that A might be obtuse? So doing A first is safe. Of course, we didn't know this because it's our first time doing a problem like this. So thank you for bringing this up. Almost went right past it. Yeah, so we have to get this first one first, and it's definitely acute. And then from there, we don't even have to worry about it. This is obtuse and specifically 106.3 degrees. Yes.
We also, since cosine inverse is in 1 and 2, if we were just to use the law of cosines to get the second angle, would we not have to worry about it?
Oh, true. But my recommendation, if you had to choose between law of sines and law of cosines, law of sines all day, yes? I think you've all gotten law of cosines, but I think you also see that it's a little bit of a pain to use. So if you could eliminate any sort of possibility for error, law of sines, or just be aware. Okay. So knowing what we know now, you can see we have three sides. Should I use law of sines? No. Okay, I want you to discuss with your neighbor what would a good starting place be here.
Yeah. So it's these for.
Yeah. Yeah,
Or they
that's
just want long signs to us. Yeah.
How do you do?
I got some. Oh, that's.
Hey, so you need to tell me
Okay, so what angle should we find first? Any of them?
that. What's this?
C? Why C? Because what? Because it's the first one. Oh, by the way, in your notes, maybe we should say not only should we use this for SAS, but also, what's that? For SSS. So you use it when you have these two cases. Okay. Now, if we find angle C first, put your pencils down for a minute. I just want to listen. If you find angle C first, using law of cosines, which is not a bad idea, it will be successful. The problem after that is that, right, Nico, you're going to be using something like law of sines, and we have the possibility of an obtuse angle. In fact, I mean, the diagram looks like we're going to have obtuse angle. Does law of sines give you directly an obtuse angle? It does not. Does cosine inverse result in an obtuse angle? Should it result in an obtuse angle? Remember, cosine inverse lives in quadrants 1 and 2. So the recommendation when you see something like this is to first find the big angle, angle A. Because cosine will reveal obtuse angle. Yes, Eileen.
Do you copy these laws after? Like,
No.
we do this law of cosine does.
Yes.
So I can find, because I found C first. And so now and then just find A, which is the.
Absolutely. You could use law of sines for A, but also check the obtuse option.
No. Equals minus.
Oh, this is, yes, sure.
Sure.
That's the one I put into the calculator, like, so, this is the stuff I did. Yeah, this was. And so. Negative. That. No way, you see.
Everybody done with the triangle?
Cosine. Interesting. So hopefully this is correct.
I'll give about 15 seconds before I call on someone, some lucky young student. Okay, Henry, can you start us off with this one, please?
So I think I should,
Okay.
but basically what we're gonna do is we're gonna take the A law of cosines. And then we're gonna substitute 9 squared plus 6 squared plus 4 squared.
But could you write the whole equation first for me, please? So,
Yeah, A squared equals B squared plus B squared equals, minus 2BC cosine.
nice. Okay, so with the numbers, it's gonna be what equals what?
9 squared equals 6 squared plus 4 squared minus 2 times 6 times 4.
That's cosine of. Okay, are we good with this? Nice, Henry. Thank you. Now, did you say you hadn't finished solving for this yet?
Yeah, so
Okay. The big thing is don't try to You could add the 6 squared plus 4 squared, right? 36 plus 16, you could add those. But please don't add that to that mess. When you're doing this, we have 81, we have 36, 16, what is this, 12 times 4, 48. If you try to add these together, it will definitely give you a wrong answer. Please don't forget about the order of operations. Who'd like to tell us what they got for A? Yes, Riaz.
127.
27.2 degrees. Do we agree? Okay, nice. So now that we have our obtuse angle out of the way, we can proceed without a care that the rest are acute. Did anyone already get B and C? Ria, can you finish this off here? What is B and what is C?
We got 32.1 degrees. We see about
27? 20.7. Okay. Any questions? Okay, that's all I got for you. I really want to give you time to work on the problem set. So take some time and I'll be checking in with you throughout. Please pay attention to the decimal places. Pardon? What is this? This problem set to do? I said by 3 o'clock, but there's no late penalty if it's done after that. So end of semester. No, it's on my math lab.
I was gonna say,
Sorry.
like, I did this.
Yeah, new assignment.